Students, I am giving the notes of inverse of a matrix. Inverse of a matrix, A is defined by A inverse, A raised to minus 1. That is A raised to minus. Inverse of a matrix A is denoted by A raised to negative 1. A raised to negative 1 equal to adjoint A by determinant A. Then properties of inverse of a matrix. Let A is a square matrix. Then if determinant A is not equal to 0, then A inverse exists. A inverse equal to adjoint A by determinant A. And AB whole inverse equal to B inverse into A inverse. These are some properties of inverse of matrix. Find the inverse of the following matrices if it exists. So A equal to 1, negative 2, 4, 3. That is 2 by 2 matrix. Determinant A is equal to determinant 1, negative 2, 4, 3. That's equal to 1 into 3. 3 minus 4 into negative 2. Then negative 8. That is 3 plus 8 equal to 11, which is not equal to 0. Therefore, A inverse exists. A equal to matrix 1, negative 2, 4, 3. A inverse exists. Then we want to find out adjoint A. A equal to 1, negative 2, 4, 3. In 2 by 2 matrix, we can find out adjoint A very easily. How? If in right side one example is given, A equal to matrix A, B, C, D. Then you round the A, D, that is first row, first element, and second row, second element. You interchange the elements, and in BC, you change the sign. It's only change the sign. So adjoint A is equal to D and A. First you interchange the values D and A diagonally, and change the sign of B negative B and change the sign of C negative C. In the same way, we can find out adjoint A here. Interchange the 1 and 3. So 3, 1. And 4, negative 2. Change the sign. Negative 2 becomes 2 and 4 becomes negative 4. So adjoint A is equal to 3, 2, negative 4, 1. Then A inverse equal to adjoint A by determinant A. That's equal to matrix 3, 2, negative 4, 1 divided by 11. You can take the 11 outside. Therefore, 1 by 11 into matrix 3, 2, negative 4, 1. The next question is 1, 3 by 3 matrix. If A equal to matrix 1, 3, 3, 1, 4, 3, 1, 3, 4, find A inverse. So determinant A is equal to determinant 1, 3, 3, 1, 4, 3, 1, 3, 4. Then expanding along R1, determinant A is equal to 1 into, we know that to find out the determinant value of determinant, then delete the elements of the column and row in which one lies. Then 4, 3, 3, 4. Then 4 into 4, 16 minus 9 minus 3 into 4 minus 3 and 3 into 3 minus 4. That's equal to 1 into 7 minus 3 into 1 plus 3 into negative 1. That is 7 minus 3 minus 3. That is 1, which is not equal to 0. Therefore, A inverse exists. Then we want to find out adjoint of A. For that, we want to find out cofactors. A11, A12, A13 capital letter, and A21, A22, A23, and A31, A32, A33. A11 is equal to this minus 1 raised to 1 plus 1, that is minus 1 raised to 2 becomes positive. We delete the row and column in which that element lies. Then we get 4, 3, 3, 4, which is equal to 4 into 4, 16 minus 9, which is equal to 7. A12 is negative, that is negative 1 raised to 1 plus 2, that is the sign negative, into delete the element, the row and column in which A12, the element A12 lies. So 1, 3, 1, 4, then we get negative of 4 minus 3, that is negative 1. Then A13 is minus 1 raised to 1 plus 3. So minus 1 raised to 4 is positive. And delete the element, row and column in which the element A13 lies. That is determinant 1, 4, 1, 3. That is 3 minus 4, negative 1. Then A21 is equal to minus of determinant 3, 3, 3, 4. that's equal to minus of 12 minus 9, which is equal to minus 3. A22 is equal to positive minus 1 raised to 2 plus 2, 4, that is positive 1, 3, 1, 4. 4 minus 3 equal to 1. A23 is a negative. Determinant 1, 3, 1, 3, that is 3 minus 3 equal to 0. The same way we can find out A31, that is 3 plus 1, 4, minus 1 raised to 4 is positive. 3, 3, 4, 3, that is 9 minus 12, which is equal to negative 3. A32 is equal to minus of determinant 1, 3, 1, 3, that is minus of 3 minus 3, which is equal to 0. A33 is equal to positive determinant 1, 3, 1, 4, that is 4 minus 3, which is equal to 1. Then at J is cofactors matrix A transpose. That is, first we can write the cofactors matrix A11, A12, A13, A21, A22, A23, A31, A32, A33 in this matrix. 7, negative 1, negative 1, negative 3, 1, 0, negative 3, 0, 1, whole transpose. Adjoint is equal to, transpose means interchange the rows and columns. So at J equal to, in this matrix, interchange the rows and columns. 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1. Either you can interchange the row to column or column to row. Then A inverse equal to adjoint A by determinant A, which is equal to matrix 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1 divided by 1. That is 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1. So answer is A inverse equal to negative 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1. The next question, A equal to 2, 3, 1, negative 4 and B equal to 1, negative 2, negative 1, 3. Then verify that AB whole inverse equal to B inverse C inverse. Here we want to find out first AB equal to 2, 3, 1, negative 4 into 1, negative 2. AB equal to 2 plus negative 3, negative 2 into negative 2, negative 4 plus 9. Then second row 1 into 1, 1 plus positive 4. 1 into negative 2, negative 2 plus negative 12. That is negative 1, 5, 5, negative 14. Then determinant AB equal to determinant negative 1, 5, 5, negative 14 equal to negative 1 into negative 14 minus 5 into 5. That is 14 minus 25 equal to negative 11, which is not equal to 0. Then AB whole inverse XS. Adjoint AB equal to negative 14, negative 5, negative 5, negative 1. Interchange the elements negative 1 and negative 14 and change the sign of 5 and 5. And AB whole inverse equal to, you can take the 1 by 11 outside and divide the elements of matrix by negative. So we get 14, 5, 5, 1. So 1 by 11 into matrix 14, 5, 5, 1. That is equation number 1. Then we want to find out A inverse and B inverse. So A equal to matrix 2, 3, 1, negative 4. Determinant A is equal to determinant 2, 3, 1, negative 4. That is negative 8 minus 3. That is negative 11, which is not equal to 0. Therefore A inverse exists. Then adjoint A is equal to matrix negative 4, negative 3, negative 1, 2. And A inverse equal to adjoint A by determinant A, that is matrix negative 4, negative 3, negative 1, 2 divided by negative 11. That is 1 by 11 into divide by negative sign the elements in the matrix. So 4, 3, 1, negative 2. Then B equal to matrix 1, negative 2, negative 1, 3. Determinant B is equal to 3 minus negative 1 into negative 2, positive 2. That is 1, which is not equal to 0. Therefore B inverse exists. Adjoint B is equal to matrix 3. Interchange the 1 and 3. So 3, 1 diagonally. And then change the sign of 1 and 2. Negative 1 and negative 2. So 2, 1. B inverse equal to adjoint B by determinant B, that is matrix 3, 2, 1, 1 divided by 1. So B inverse equal to 3, 2, 1, 1. Then B inverse A inverse equal to matrix 3, 2, 1, 1 into 1 by 11 into 4, 3, 1, negative 2. Take 1 by 11 first. 1 by 11 into matrix 3, 2, 1, 1 into 4, 3, 1, negative 2. That is 1 by 11 into 3 into 4, 12, plus 2 into 1, 2, 3 into 3, 9, plus 2 into negative 2, negative 4, and 1 into 4, 4, plus 1 into 1, 1, and 1 into 3, 3, plus 1 into negative 2, negative 2. Then B inverse A inverse equal to 1 by 11 into matrix 14, 5, 5, 1. Then from 1 and 2, 1 and 4, we get AB whole inverse equal to B inverse A inverse. I hope that you understood that the properties of inverse of matrix and to find the inverse. So in the next class I will give solution of linear equations using matrix method. Please, if you like the video, please click the like button and share this to all your friends, and have any doubt please ask in the comment box. And if you are watching this channel for first time, please subscribe it. Thank you.